All right, so looking here at molar mass and percent comp, going to take a look at these concepts. They're not too hard. This is probably the easiest math of the math. All right, so what are we going to learn today? Defining molar mass and percent comp. We're going to also determine the number of atoms of each element in the compound, because you need to know that in order to calculate the molar mass of the compound, and calculate the percent composition of an element in a compound. All right, starting with the counting atoms. And hopefully you got these from the compounds activity where you hinted to what did the subscripts in the parentheses tell you. So if I'm looking at P2O5 here, P2O5, how many atoms of P do I have here? 2. Good. How many atoms of O do I have? 5. Now there isn't a third atom, so we're just going to leave that one blank. 2 plus 5, of course, gives us a total atom count of 7. Now if we're looking at this particular one, which is a polyatomic ionic compound, NH4 plus we just talked about, that's ammonium. And if you look at your list of polyatomic ions, you'll see that OH is one of them. It's called hydroxide. And hydroxide, of course, is responsible for making things basic or alkaline. All right. Looking at this compound that does have 3 different elements in it, has nitrogen, hydrogen, and oxygen in it. How many nitrogens do we have? When there's no subscript, it's an understood 1. Very good. Now, how many hydrogens do we have? Good, 5. If you look, there's 4 here, and then there's the 1 on the end. That's a little deceptive, so watch out. How many oxygens do we have? Only 1, so that's a total of 7 atoms as well. Now we're going to get into the parenthesis fun. Hopefully you got to this point too, where you got to see how many berylliums do we have? Just the 1. Now, we have parentheses around our hydroxide. What do you do with numbers when they're outside parentheses? Or you would typically do that in math as well. Distribute, multiply. Yeah, okay, it has to distribute to both things inside the parentheses, and you would multiply it. So that means there's 2 oxygens, but that also means there's 2 hydrogens. So that's a total of 5 atoms. Now let's look at this last one, this aluminum sulfate here, Al2SO4. How many aluminums? 2, good. How many sulfurs? 3, distribute that 3. So that's 3 times 1, and then how many oxygens? Definitely distribute that 3. Yes, that would be 12. So 3 times the 4 gives us 12. That's a total of 17 atoms for that particular one. Now let's talk about ions. Counting the ions in there. Now looking at your first compound, are there any ions for P2O5? No. What type of compound is P2O5? Because P is a nonmetal, O is a nonmetal, so what type of compound would that be? Would it have ions? No. So it'd be covalent. Very good. So no ions in a covalent compound because they're sharing electrons. They're doing it differently. But we know this one has an ammonium. We know this one has a hydroxide. So 1 ammonium ion, 1 hydroxide ion. That's a total of 2 ions. However, if we're looking at this one where we have parentheses, how many beryllium ions do we have? How many berylliums? Just one. And what's our charge on our beryllium? Do we remember that? It's over here, up in your alkaline metals. So it's going to be +2. So there's one Be +2. And then hydroxide here, we know it's OH minus. How many of those we got? We have 2 hydroxides, and that gives us a total of 3 ions. Now, we talked about aluminum before. What's the charge on aluminum when it's an ion? Group 13 here. Aluminum +3, good. There's 2 of them. And sulfate, if you go look up sulfate on your polyatomic chart, you'll know it's SO4 minus 2. And there's 3 of them. So 2 aluminums, 3 sulfates, which is a total of 5 ions in that compound. All right. Now, molar mass of any compound is the mass in grams of 1 mole. So that's the overall definition of what molar mass is defined as. Now, how do you find molar mass? It is summing up the masses of all the atoms represented in the chemical formula. So we need our periodic table for this because we have to look up their masses on the periodic table. Remember, the mass number is always this decimal number on the periodic table. Now, if I'm looking at this particular formula, CH4, which is methane gas, there's 1 carbon and 4 hydrogens. So I have my 1 carbon, that's going to be 12.01. Hydrogen down here is 1.01. There's 4 of them, so I need to take my 1.01 and multiply it by 4 for the hydrogen, and then I can add them up together and I get my entire molar mass. Now, what you need to note here too is molar mass unit is always grams per mole. So it's G/mol. Now, for the periodic table, any periodic table that you're using, I want us all to have the same numbers. So we're going to all round to 2 decimal places. What does that mean when we're rounding to 2 decimal places? Like for calcium here, it's 40.078. Well, we're going to all just round to 2 decimal places. So the 8 rounds up to 7. I'm going to do calcium is 40.08. So here's hydrogen, 1.008. That's why we always make it 1.01. Looking here at oxygen, which is 15.999. What would we round that to? Two decimal places. When you have the 999 like that, what do you do? Yeah, it just becomes 16.00. So any of these in here, like this one's already to 2 decimal places, that's great. But like this one, copper, 63.55. I want everybody to only go out 2 decimal places. That means we'll all have the same molar masses. So 2 decimal places is the general rule that we use. Now, percent composition is really just a percent. And if you know the general formula for percent, it's always going to be the part over the whole times 100. Now the part is going to be our mass of our particular element, and then of course the whole is the total mass of the compound. So when we're looking for the percent by mass of one particular element, you always take the element's mass divided by the entire mass times 100. And we can do a lot with these numbers, so it's important obviously to be able to calculate a percent composition. Let's do an example, a very easy example. What is the molar mass of magnesium fluoride? Well, magnesium fluoride, I like to set it up sort of like a little table here, but what do I need in order to figure this out? What important tool do I need? Anyone? Where do I find my masses? Periodic table. Very good. So I need the periodic table. Here we go. At least we have the periodic table. Okay, so if I find magnesium, looking here, 24.305, I'm going to make that 24.31, rounding to 2 decimal places. If I look over here at fluorine, what do I round that one to? Fluorine, 18.998 is going to round to, just like oxygen did. It's just going to round up to the next whole number, 19.0. Yep, exactly right. Now that I know the masses, I can get rid of the periodic table and keep calculating. How many magnesiums do I have in my compound? Just the one, so, multiply by 1, 24.31. Multiply this one by what? Fluorine gets multiplied by, at our compound 2, so that's 38. Then all I have to do is add these together. So I end up getting 62.31 grams per mole. That is my molar mass. Now, once I know my molar mass, guess what? I can easily calculate the percent mass of each of the particular elements. So calculate the percent by mass of fluorine in here. So all I would need to do, percent by mass of fluorine, well, I need the mass of fluorine divided by the mass of MgF2 times 100. Now, you don't have to write this part out. I just want to show you how I'm applying that equation. What you would need to write out here is the 38, the mass of the fluorine over the entire compound. This is the work that I would need to be shown. Then you get out your handy dandy calculator and you do 38 divided by the 62.3 and multiply that by 100. And for percent purposes, we're always going to go to 2 decimal places as well, just to make it easy. So this would be 60.99%. And that would be the final answer there, which is correct. Let's do one more example. Let's practice. That's pretty much all we have time for, but let's go ahead and do this. Aluminum thiosulfate. Let's take a look at this one. So this one has 3 elements, Al, S, and O. Now, it looks like here I have 2 aluminums. How many sulfurs are going to be in this particular one to calculate with? How many sulfurs? 3 times 2 gives me 6. And then how many oxygens? 9. Good. Now I need my periodic table. Where's aluminum? It's over here. Here's aluminum. 26.98. 26.98. Sulfur, 32.06. And oxygen's easy because that's always going to be 16. Once I look those up on the periodic table, now I can finish my calculation. So we get 26.98 times 2 is 53.96. 6 times 32.06 is 192.36, and 9 times 16 is 144. Now, of course, you need to show work on this in the beginning, but as we get more into the math later on in like unit 7 and 8, you won't have to show how to calculate molar mass every time. So you add all this up to get the entire molar mass, which you need for percent comp anyways. And this one's going to be 390.32 grams per mole. Now it wants the percent of mass of oxygen here. So I need my oxygen number, which is 144, over my entire mass, which is 390 times 100. And this is going to give me my percent of O. Just calculate that real quick. And the percent by mass here is going to be 36.89%. So not too difficult in terms of the math. However, I'm going to show you one more example next time about hydrates. It's a slightly different, but not really that much more difficult. So it's 1:19. So we're going to end class or end notes for today.